Right, okay, let's take a look at these questions then. So the key bits of stats that you need to recall in order to be able to access these questions are that if you've got two events, A and B, if they are mutually exclusive, then there'll be no intersection. So probability A intersection B will be 0. And on a Venn diagram, that would mean that you'd have that. If they are independent, then the intersection would be the product of their probabilities. So you've got the probability of A intersection B equals probability of A times the probability of B, and then your circles will intersect. And then you've got the general rule of probability. And the general rule is the union, so the probability of them being in A, B or both is the sum of their probabilities less their intersection. Okay, and the A union B, if we were shading that on the Venn, that would be everything that's inside that circle, the two circles. Everything that's outside the circles would be the probability of not in A and not in B. So that would be 1 minus the probability of the union. And we use that in these questions too. Okay, so with all that in mind then, let's take a look at what we've got. So question 1, the events A and B are such that the probability of A is 0.45. That hasn't copied very well. Probability of B is 0.3 and the probability of the intersection is 0.25. Calculate the probability of A union B. So the probability of A union B, so that's straight from that general rule, is going to be the probability of A, which is 0.45, plus the probability of B, which is 0.30, less the intersection. So we've got 0.45 plus 0.3 less 0.25, 0.5. And then part B, the probability of it not being in A union B. So the probability of it not being in A and not in B would be 1 minus the union, which would be 0.5. So that's question 1. Question 2 is more like a GCSE question. So Amy and Bethany each throw a fair cubical die with the faces numbered 1, 2, 3, 4, 5, 6. Calculate the probability that the score on Amy's die is equal to the score on Bethany's, greater than the score on Bethany's. So to do this one, we would draw a sample space diagram, which, as I said, is something that you would have come across back in Key Stage 4. We list all the possible outcomes from the event of Amy and Bethany throwing a die. So if I have Amy up the top, she could throw a 1, a 2, a 3, a 4, a 5, or a 6. And Bethany could also score 1, 2, 3, 4, 5, 6. So the possible outcomes would be Amy throwing a 1 and Beth throwing a 1, Amy throwing 2, Beth throwing 1, 3 1, 4 1, 5 1, 6 1, or Amy throwing 1, Beth throwing 2, Amy throwing 2, Beth throwing 2, Amy throwing 3, Beth throwing 2, 4 2, 5 2, 6 2. Amy throwing 1, Beth throwing 3, Amy throwing 2, Beth throwing 3, 3 3, 4 3, 5 3, 6 3. Amy throwing 1, Beth throwing 4, 2 4, 3 4, 4 4, 5 4, 6 4. Amy throwing 1, Beth throwing 5. 1 5, 2 5, 3 5, 4 5, 6. Amy throwing 1, Beth throwing 6, 2 6, 3 6, 4 6, 5 6, 6 6. Okay, calculate the probability that the score on Amy's die is equal to the score on Bethany's die. So how many times are the scores equal? Well, you'd have the 1 1, 2 2, 3 3, 4 4, 5 5, 6 6, 1 2 3 4 5 6 out of a total of 36. So A1 P equal a score will be 6 out of 36. What about Amy having a score which is greater than Bethany's? P Amy greater than Beth. So let's take a look. So Amy is the first number, Beth is the second. So for Amy to have a score greater than Beth, we've got 1, all of those, all of those, all of those, all of those, and that one. So out of the 36, you've got 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 out of 36. B. Given that the sum of the scores on the two dice is 4, find the probability that the two scores are equal. So probability equal given total of 4. So if we look at how many possible ways there are of scoring a total of 4, we've got 1, 2, 3. Those are the only ways we're going to have a total of 4. So it's going to be out of 3 because we're given the total 4, and the number of those where the scores are equal is 2 2. So there's only one. Oops, you couldn't see that, sorry. Probability equal given a total of 4. So we figured out that we already know there's a total of 4, and there are 3 possible outcomes. So it's going to be out of 3, and there's only one of those combinations where the scores are both the same. So it's 1 out of 3. Question 3 then. So question 3. A and B are two independent events. So it's important they're telling us that the events are independent. So therefore we know that the product of A and B will give us the intersection. And they're also telling me that probability of A is 0.3 and the union is 0.5. So if we use the general rule, A union B is the probability of A plus the probability of B less our intersection, and let's put in what we know. We know the union is 0.5. We know the probability of A is 0.3. We don't know the probability of B, but we do know that this can be written like that. So we're going to have minus the probability of A, which is 0.3, times the probability of B. So 0.5 equals 0.3 PB minus 0.3 PB. Treat that as a piece of algebra, like x take away 0.3x. So that would be 0.7 PB. Take the 0.3 across, becomes a subtract, so we get 0.2 equals 0.7 PB. So therefore PB will be 0.2 over 0.7, which is 2 over 7. So that's A. B. Calculate the probability that exactly one of the two events occurs. So it'll be helpful to draw a Venn diagram of the information that we've got there now. So I know I've got an intersection A, B, and I can work out that my intersection would be probability of A, which is 0.3, times the probability of B, which is 2/7. If I do 0.3 a bit more light there, 0.3 times 2 over 7 is 3 over 35. So I know that this bit in the middle here is 3 over 35. I know that probability of A is 0.3, so that's going to be 0.3 less that, which is 3/14. I know the probability of B is 2/7, so 2/7 less 3/35 equals 0.2, so that's going to be 1/5. That's what 0.2 is. And the probability of exactly one of them occurring is going to be that probability or that probability. Because this section means only A is occurring, and this section is only B is occurring. So exactly one event will be 3 over 14 plus 1 over 5. equals 29 over 70. Okay. Probably get one more in before I need to do a lesson changeover. So question 4. So question 4. Refocusing a bit. The events A and B are such that the probability of A is 0.4, B 0.35, and the probability of it not being A and not in B is 0.4. So that's outside the circles in the Venn diagram. Determine whether A or B are mutually exclusive, or if A and B are independent. So given probability A and not B is 0.4, we know that the union is going to be one less that, which is 0.6. We can now use the general rule to work out what the intersection is. If the intersection works out to be 0, we know they're mutually exclusive. So 0.6 equals 0.4 plus 0.35 so the intersection would be, take that over to make it positive, bring this back over, 0.4 plus 0.35 minus 0.6. So that's going to be 0.15, not equal to 0. Therefore, A and B aren't mutually exclusive. We can then test to see if they're independent, because if they're independent, the product of those two, 0.15. The intersection. And we've got probability of A, 0.4 times 0.35 does not equal 0.15 because it equals 0.4 times 0.35 equals 0.14. Therefore, events aren't independent. Okay, so I'll stop there while I go and change over, and then I'll come back and do the rest. Right, back from changeover, question 5. So two independent events A and B are such that probability of A occurring is 0.4, probability of B occurring is 0.3. It's telling me it's independent, so I know, so given events are independent, therefore I know that their product gives me the intersection. Find the intersection. So probability A and B will be 0.4 times 0.3, which is 0.12. A union will would be the probability of A plus the probability of B less the intersection. So that's the general rule. So we got 0.7 less 0.12, which is 0.58. He says, doubting himself. Hang on. Brain's gone to sleep now to be out in the cold. .58. The probability that neither A nor B occurs, so that's going to be 1 minus the union. That's going to be outside the two intersecting circles. So probability neither occur would be 1 minus the union, which should be 0.42. So that's number 5. Number 6. Two events A and B are such that, so I'm given probability of A, B and the union. It's not telling me they're independent, so I can't just multiply them. I've got to use the general rule. So for A union B is A plus B minus the intersection. So the intersection would be 0.4 plus 0.2 minus 0.5, which is 0.1. Determine whether or not A and B are independent. Well, if they're independent, then the intersection would be the product. Intersection I know is 0.1, and then I've got 0.4 times 0.2, and I know that that's not equal because that's going to be 0.08. So not independent. Handwriting has gone awful. So that's question 6. Question 7. Give myself a bit more space. Events A and B is such that, so this time it's pretty much the same as above. So show that A and B are independent, so we need to use the general rule to calculate the intersection, and then show that the intersection I can also get by multiplying 0.2 and 0.4. So using A union B is A add B minus intersect 0.52 plus 0.2 plus 0.4 minus the intersect. So the intersect equals 0.6 less 0.52 equals 0.08. Now, probability of A times probability of B would be 0.2 times 0.4, which equals 0.08, which equals intersection. Therefore, events are independent. And then for part B, calculate the probability of exactly one of the two events occurring. So that's going to be, in my Venn diagram, the two little moon shapes. So let's see what we can put in here. So that's A, that's B. I know the intersection is 0.08. Which isn't going to fit. 0.08. A is 0.2, which means that's going to be 0.12. B is 0.4, which means that's going to be 0.32 in order to add up, and then exactly one occurring is going to be the 0.12 or plus the 0.32. So it'll be 0.12 plus 0.32, which would be 0.44. So that's question 7. Question 8. Events A and B are such that evaluate the union in each of the following cases. A and B are mutually exclusive. So if A and B are mutually exclusive, so if we look at A union B, probability of A plus the probability of B minus the intersection. For A, mut exc, there is no intersection. So therefore, probability of A or B will be 0.3 plus 0.4 minus 0 if you like, equals 0.7. And if they're independent, which I'm getting fed up with writing, then the intersection will be 0.3 times 0.4, 0.12. So the union will be 0.3 plus 0.4 less 0.12, which will be 0.7 less 0.12, which is going to be 0.58. And then the final one. Events A and B are such that probability of A occurring is 0.2, probability of B occurring is 0.3. Determine the value of union when. So let's write the old general rule out. Mutually exclusive. Meaning there's no intersection. So it will be 0.2 plus 0.3. 0.5. Independent. Intersection will be the product. 0.2 times 0.3 is 0.06. So now our union will be 0.2 plus 0.3 minus 0.06, 0.5 less 0.06, 0.44. And C, A is a subset of B. Means that the probability of B occurring, A occurring, is already in that probability. Because what we got here is B and A is sitting inside it. So the union is just going to be the probability of B occurring. Because if B occurs, A has to occur or has already occurred. So that would just be probability of B, which is 0.3. Okay, so hopefully, if you're struggling with those, hopefully you will have got into the rhythm of them by the time you get to that at the end of that.